Good afternoon, sir.
Good afternoon. I'm audible.
Yes, sir.
Okay.
We will start the session.
Yes, ma'am.
Thank you, sir. So, good afternoon, distinguished guests, faculty members, participants from various institutions. A dream written with a date becomes a goal. A goal broken down into steps becomes a plan. A plan backed by action makes your dreams come true. With a beautiful quote, I am Renuka Devi, Assistant Professor, Department of Mathematics. Welcome you all for the National Level Faculty Development Program on Data Driven Insights on Application of Mathematical and Statistical Modeling, organized by Department of Mathematics in association with IQAC, St. Joseph College, Arts and Science. It's a pleasure to have you all join us virtually. Let's start the session by invoking the presence of Lord Almighty. For that, I would like to call upon Mrs. Bhavani, Assistant Professor, Department of Mathematics, to begin the session with prayer.
Heavenly Father, we thank you for this opportunity together in your presence for this faculty development program. We ask to glorify your blessings on our founder, Reverend Father Dr. J. Arulraj, beloved Administrator Reverend Sister M. Baby, Principal Dr. R. Ruban, and our today's resource person, Dr. V. Selvakumar, Assistant Professor in the Department of Mathematics Statistics in Bhavan's Vivekananda College of Science, Humanity and Commerce, and all the faculties of various institutions. God guide our mind and heart as we what we learn in this session. Help us to seek your truth, to grow in knowledge and wisdom, and to put into practice the things we learn. Thank you for your grace and mercy and for your loving kindness. We humbly ask this prayer in the name of our Lord. Amen.
Thank you, ma'am, for your soulful prayer. Now I request Mrs. Sujata, Head Department of Mathematics, for the welcome remark and introduce the speaker for this day.
A very good afternoon, one and all present here. With the blessings of God, the Almighty, and the wishes of our founder chairman, Reverend Father Dr. J. Arulraj, I welcome you all for the 5 days national level virtual FDP on data driven insights on applications of mathematical and statistical modeling. The main aim of conducting this FDP is to get leadership qualities, pedagogical expertises, and individual development. On behalf of our management and the Department of Mathematics, it's my great pleasure to welcome our today's resource person, Dr. V. Selvakumar, Assistant Professor, Department of Mathematics and Statistics, Bhavan's Vivekananda College of Science, Humanities and Commerce, Secunderabad, Telangana, who will be presenting in the title Time Series Modeling and its Applications. Thank you, sir, for accepting our invite. Welcome you, sir. I wholeheartedly welcome our beloved Administrator, Reverend Sister M. Baby, and our eminent Principal, Dr. R. Ruben Sir, for their guidance and support to conduct this FDP. Welcome, sir. Welcome, sir. I extend my warm welcome to all the faculty fraternities and research scholars from various colleges and our colleges. We hope all the participants will be benefited and get substantial improvement in the educational context through this FDP. Once again, I welcome you all.
Thank you, ma'am, for your warm welcome. Now I request Mrs. Flora Evangel, one of the coordinator for this FTP, to give a brief introduction about our speaker.
Thank you, ma'am. It's my privilege in introducing our today's resource person for this FDP program. Dr. V. Selvakumar is an assistant professor in the Department of Mathematics and Statistics in Bhavan's Vivekananda College of Science, Humanities and Commerce, Secunderabad. He did his PhD from Pitts Pilani, Hyderabad, and he has 23 years of experience as an academician as well as a researcher. He published more than 31 papers in international and national journals. He has 5 patents and has authored 4 books. He also presented more than 15 papers at national and international conferences. His areas of interest are data analysis, time series modeling, actuarial science, machine learning, and predictive modeling. On behalf of St. Joseph's College Arts and Science, I wholeheartedly welcome you, sir, for today's session.
Just I'm sharing the slide, ma'am. 1 minute.
Okay,
Is
sir.
it visible? Yeah. Is it visible, ma'am?
Yes, sir.
Okay. Yeah. So good afternoon to everyone. I am Dr.V.Selvakumar, Assistant Professor from Bhavan's Vivekananda College, Sainikpuri, Secunderabad, Telangana. I did my PhD in BITS Bilani, Hyderabad, under the topic, especially in the time series modeling, empirical modeling and predicting motor insurance claims using different machine learning approaches. I'm deeply honored to have an opportunity to be a resource person for this prestigious 5 days national level FDP applications of mathematical and statistical modeling. I thank Principal Dr. R. Ruben, St. Joseph College, and Head Department of Mathematics, Mrs. K. Sujata ma'am, and Dr. G. Manimannan sir, and all other faculty members to giving me an opportunity to share my knowledge to all of you. Thank you all for being here, and I look forward to a meaningful and enriching session together. So I am going to give more talk, especially in practical oriented application of time series modeling, not in theoretical things. When coming back to the time series modeling and its application, especially over the past few decades, an emerging research area that has grabbed many researchers' attention in time series modeling. The main goal for modeling the time series is to develop an effective model that accurately generate the serious inherent structure of the model. Then this model will be used to estimate possible values of the sequence that is to be used to predict the future values. So, while time series forecasting especially is critical in various functional areas, therefore we should take careful attention should be given for finding the suitable model to fit the underlying time series model, especially a critical importance of good model design in various functional area which including industry, economics, finance, research and engineering. A successful time series forecasting technique which we have developing is to predict an appropriate model fitting. Especially in if we coming back to the simple definition, a univariate time series model as a realization of sequence of data points that are usually collected over a period of time. It is mathematically defined as x of t. T is the time period of 1, 2, 3, 4, where t denotes the elapsed time. The x of t here we represent the stochastic process of the random variable. Okay. So, in basic definition, time series is nothing but the measurement of collected data, which is to be organized in chronological order. That means with respect to the time period. We know, all of us, we know that there are 4 main components of time series we always studied in the UG level, undergraduate level, that is secular trend, seasonal variation, irregular variation, and cyclical variations. But successfully applying the time series model is very, very important, especially in a time series, historical observations which is to be gathered and evaluated in order to build the mathematical model that accurately predict the series. This model will be used to identify the forecast the future accuracies. Especially forecasting the time series data is critical in variety of areas. Sometimes, which is critical strategic, we have to apply the strategic initiatives and preventive actions which are to be made in view of forecast results. So especially the many applications, if you see, the time series will be applied in many applications which is related to finance, economics, weather forecasting, healthcare, and more. Here are some of the common applications where the time series is used, especially in finance forecasting. Okay, predict the stock prices, especially currently exchange rates, predicting the exchange rates or commodity prices and other financial indicators. This prediction or forecasting assist the investors, traders, and financial institution in making, especially making the decisions, especially in demand forecasting, to forecast the demand for the product or services. This helps optimizing the inventory of the management, and also they can plan for production planning and supply chain logistics. In sales forecasting also, we can especially nowadays retail and e-commerce companies use time series models for predicting the future sales of the volumes. This implementing the marketing combined planning and also resource allocation and revenue projection. Especially in economics, if we take economic indicators such as GDP growth, unemployment rates, inflation rates, and the consumer spending expenditure are very, very important to forecast to formulate the economic policies also. Coming back to the energy consumption forecasting, especially to forecast the electricity demand and consumption pattern, which gives the efficient resource allocation and capacity planning and pricing strategies of the government. Time series modeling nowadays is very important in weather forecasting also. Meteorological use of time series analysis to forecast the weather condition, including the temperature, wind speed, and humidity. And accurate weather forecasts are crucial for disaster preparation, as well as the agriculture and transportation, and various other sectors. Especially in healthcare industries, predicting the patient admission and diseases, how it is outbreak, especially in the COVID situations, and medical resources, predict the medical resources utilization and healthcare cost also. This helps the hospitals and healthcare providers use this forecast for resource planning and capacity management. Also, the traffic transportation agencies use the time series modeling to predict the traffic congestion, how that particular road having that particularly, especially for the peak hours, how to manage. So this assists the traffic management and urban planning people to improving the transportation of the efficiency. Especially in supply chain management also, time series plays very, very important role to forecast the inventory levels and order quantities and delivery times in supply chain operations. Quality control also, manufacturing the industries which use the time series models to predict equipment failures, detect, yeah, especially what are the fault it is happening in the production process, and also they will maintain the product quality. This helps to reduce downtime and improve the efficiency and minimize the defects in the time series model. Therefore, there are a lot of application, especially in insurance industries also, to forecast the claim amount. It will help the insurance companies to settle the claim on time, as well as they can keep some resources allocation also. So there are many application in the field of time series modeling. So especially for the research is concerned, we can take any one of the model, we can apply. Only thing is getting the data is very, very difficult. You have to go through the data in the especially for the government website and take some 20 years, 40 years or 50 years data and predict the future outcomes. Building so it's not only one model application, applies so many techniques of time series simple modeling techniques and also ML. Now it is going to the deep learning model as well as the hybrid models. We have to implement all the models put together. Which model give the better accuracy rate or error should be reduced? That model will be the best model, which helps the government sectors or companies to see the future forecast of the particular topic. Okay, so here uh, for predicting forecasting or predicting the time series model, very, very important thing is data pre-processing. Data pre-processing, the first foremost technique for model building, especially for the data cleaning. There are so many steps will be there: data cleaning, timestamp, resampling, normalization of data, train and test split of the data, and sequence generation and handling seasonality and trend in the data set, even future selection and handling categorical variables. These are the so many data pre-processing steps we have to see once the data has to be taken. Especially for the data cleaning, we have to identify the outliers or errors in the data. Especially the missing values can be filled with using interpolation method, or sometimes it will be replaced with a suitable value, especially the mean or median, depends upon the data set which we are taking. Especially for the time series modeling, if you take the values from the last 20, 50 years or 60 years database, if you found some missing values, if you apply the mean to replace the missing value, that may not give accurate result. So based on the data set, you have to decide how to handle the missing values. Especially timestamp, if your time series data is not already in the date time format, especially timestamp, if it is not in the date time format, we have to convert the data set into timestamp column into the data time object. This enables us easier to manipulation and analysis of time, especially resampling, depending on the frequency of your data, how much frequency you are taking. It may be 15 lakhs data or 20 lakhs data or 13 lakhs data, and depends upon the frequency of your data and the forecasting horizon. We should need the resample the data due to the different frequencies. Example, maybe it may be the data has to be handled by monthly, or sometimes if the data has to be handled by yearly wise, or it may be day wise. Depends upon your data, we have to decide the resampling of the data. As well as especially normalization is also very very important, and scaling also. Scale the future to a similar range to prevent the certain features dominating the others. I'm audible, ma'am? Any problem? Any one of you reply me? Hello? Hello? Ma'am, I'm audible?
Yes, sir, you're audible, sir. Good,
Okay,
sir.
okay. Some noise came. Yeah, yeah, yeah.
Okay, sir.
Okay, so I'm carrying forward. Yeah. So normalization technique, mostly we will include minimax scaling or standardization procedure, which is called Z score. We convert it into Z score of normalization technique for our database, and come make it as the data should be in normal form. Then we can implement. Especially train and test splitting the data into training and testing. Especially in most of the data set, most of the researcher will go with the 80-20 ratio or 70-30 ratio. That is 70% is the training data set, or 30% is testing data set. This depends upon the data set what you have taken into consideration of your research or modeling. Based on that, you can apply, or you can apply that all the ratios, especially 60-40, 75-25, 70-30, and 80-20, and check which values will give the minimum error value that you can consider as your model building. Then especially for the sequence generation, depending on the chosen modeling approach, whether you are taking the auto-regressive model, that is the advanced model, or AR model, or recurrent RNN, recurrent neural network, convert the time series data which is given into sequence suitable to input the model, which create the output pair where the input is sequenced to the historical data, the output will be forecasted. Handling seasonality, sometimes the data what we have collected, it retrend the data. If there is a clear trend is present, either it is upward trend or downward trend, we have to differencing the series. The technique has to be called as differencing the series, and remove the seasonality effect through the seasonal differencing or seasonal decomposition technique. Then we have to handle the data of pre-processing. After pre-processing, we have to apply the modeling techniques. And future selection, select the most relevant feature which is very very important for modeling the time series model. Especially if we have large number of potential predictors, so we have to select the particular features by using the correlation techniques, especially confusion matrix. We can say a confusion matrix. If we have only one dependent variable which have a lot of independent variables, use the confusion matrix to identify which variable is more influencing to predict the response variable. Those variable has to be handled. And also in confusion matrix we can identify the multicollinearity concept also. Two independent variables are highly correlated, this will affect our result, it will go to the overfitting of the model. So we have to apply the confusion matrix also to check if you are going for more future selection. Handling categorical data, if the data consists of categorical variable, so we have to encode them appropriately using technique, any technique, one hot encoding or label encoding. So one hot encoding and label encoding is nothing but in one hot data we will form assign directly values, zero, make it as a vector 100 010 001. If you have three variables are there, suppose your data set of the categorical variable consists of three names, say for an example ABC, again ABC, like that it is replicated. Okay, your data is say in the instead of ABC we say north zone, south zone, east and west. There will be four zones. Your data has to be collected. That particular column consists of uh, the particular column will consist of categorical variable. So we have to assign the values for the one hot encoding is nothing but if it is first is east zone, we can put one, west, east, west, north zone, west, north, and other zones we have to put 00. So it will form a vector. So convert each categorical variable into binary vector, which is creating the new binary columns. That will be binary columns, four columns will be created. That is called one hot encoding. Otherwise, you can go for the label encoding. That means assign a unique numerical values, any numerical labels which should be assigned to the categorical variable. Say north zone or south or east or west, I can assign north is 1, south is 2, east is 3, and finally west is 4. Assign a particular one. Either you have to form a vector variable or you can encode directly. This is the encoding technique you have to handling when going for the categorical variables. This pre-processing is very very essential for any time series model. Then
Sir,
one you can build the
sir, your screen is
yes
not
ma'am.
moving, sir.
Yes ma'am, I'm in the things only ma'am, I'm moving down. Okay. Now ma'am.
Ah, okay, sir. Now moving, sir.
Yeah, I'm telling the data pre-processing now. Yeah.
Okay, sir. Okay.
So coming back to the methodology, especially modeling the time series, the simple methodology which is used to build the model is linear regression. Most of the we'll start with the linear model only. This linear model will allows a time series allows to build the linear relation between the two variables, that is the response variable as well as the predictor. The simple general linear regression model structure is given by yt equal to beta naught plus beta 1 xt plus e of t. Here xt stands for the time variable in yearly unit, year-wise unit, and yt is the response variable, et will be the residual error term. And next model, we call it as exponential smoothing. This is the basic models which we started with the modeling the time series, especially exponential smoothing. In this methodology, this model depends upon the assumption that exponential decreases in the weight for the past data, especially weighted mean of the past data, which is used to forecast the time series model. Coming back to the next advanced model, that is autoregressive process. In autoregressive process, the current values depends upon the past value. That means if you see the equation of air of p is the parameter, it clearly indicating that yt, if I want to find out the yt, if yt will be depends on mu is the vector, is the constant, plus alpha 1 yt minus 1 yt minus 1 plus alpha 2 of yt minus 2 etc alpha p of yt minus p plus error term. So the current value of yt will be depends upon the past values yt minus 1 yt minus 2 etc yt minus p. This is the univariate time series model when we are applying the concept. Then moving average, coming back to the moving average process MAQ model. In this model, in the time series model, the moving average value especially have an indirect effect of previous value as well as previous random error. The current value will be depends upon the indirect effect of the present value of the process as well as the previous random error. The difference between here it is the yt, the current value will be depends upon the constant plus et plus beta 1 of et minus 1 plus beta q of et minus q. Here it depends upon the previous value. Here yt will be depends upon previous error terms. Next will be combination of the combining these two models, that is AR and MA. We have the model which is called as AR-MA model. This is the combination of two distinct model of AR of P and MA of Q, which is combined. We can get it of AR-MA of P comma Q. This model, which include the dependency between the past value as well as past value, it will take the past value as well as the past error value. So combining these two equation, we can able to get the ARMA model. Especially next, that is the very, very important model is ARIMA PDQ. In order to apply any ARIMA model to the data efficiency, the model needs to be stationary. Okay, this was given by the mathematical equation was given by Box and Jensen. It is a process can be expressed here, the model structure. Especially the model needs to be stationary. When the TP, especially if you are taking the any claim data, any data, if the data is not stationary, what is the meaning of not stationary here? It shows any trend. Maybe it is increasing trend or decreasing trend, or any cyclical trend will be there. Okay, if it shows any trend, to bring the data, it shows the non-stationary form. So to bring the data into stationary process, therefore then we have to, the original data can be reconstructed by differencing the series. That means we integrating the difference series to convert into stationary form before applying the ARIMA PDQ model. So here we have to, what is the meaning of differencing the series? If you have the series of YT, that is a time series model, say stock prices values. So you have to difference means the first difference is nothing but the second value minus first value. You will get the difference series of the first value. Again third minus 2, again 4 minus 3. That we have to find out the delta t. This delta is the difference in the series. Then we have to apply the ARIMA. Especially ARIMA model is used whenever the data, once if you plot, it shows some trend, it is not showing any stationarity. So bring the data into stationary series, then we have to apply the ARIMA model. The next very, very important model nowadays, many researcher will implement that artificial neural network in a machine learning approach. That ANN is widely used model in prediction of especially non-linear and complex problem, which is the one of the main techniques used by machine learning model. Especially in feed forward propagation, the signals are transmitted from one neuron to another for forward direction only. These are the weightages here, the input variable, and the weighted sum will be taken, and so this is the step function which is called as activation function, and it will give the output value. This is the single layer perceptron. The equation will be given as yt equal to alpha naught plus summation of alpha I. This is the activation function here, and here alpha y is the weight of the hidden layer output of nodes, and beta dot j is the weight from the input hidden, and f is the activation function ai. So if we see this multi-layer perceptron here, especially multi-layer perceptron, here if you see the layer, there are three input layers, three layers. One is input layer, the next one is hidden layers, and output layer. If you see here, there is no connection between the neurons of the same layer, no connection from the higher to lower layer, which has the input, output, and hidden layers between that. The output layer has the neurons. Output layer also has the neurons equal to the number of classes which we have. The nonlinear function, this nonlinear function which is called as activation function, which allows the network to learn complex relation between the input and output here. The simple structure of this calculation says how many neurons here. There are 5 plus 4, which is equal to 9 neurons, not counting the input. If you are not counting the input, you have hidden layers are 5, 1, 2, 3, 4, 5 hidden layers, plus output layers are 1, 2, 3, 4 output layers. So total number of neurons, not counting the input, which hosts 9 neurons. And if we find out the weights, 4 into 5, that means input is 4 and hidden layer is 5. All each input will be connected with all the hidden layers. So each input of that 4 input is be connected with all the hidden layers. Therefore 4 into 5, again this hidden layers whichever there in the middle, which will be connected to the output layer, all each hidden layer will be connected with all the output layers. So 5 into 4, total weights are 4. This structure clearly indicating that this is the linear separation of neurons, this one. Okay, it is clearly dividing the two part, but if you see the interconnection of neurons to learn complex boundaries, this is the complex boundaries, interconnection of neurons by complex boundaries. Next model, coming back to the model, is hybrid model. This is the combination of AN as well as ANN as well as ARIMA model. This was proposed by John, which consists of linear as well as non-linear domains. We have to apply the linear as well as non-linear domains. In his approach, first he modeled the ARIMA model for the original data. For the linear part, what is the residual, that is the error terms which is coming through the ARIMA model. First apply the ARIMA model for the given data set. What is the residual is coming from the ARIMA model, EI value, that has to be applied by ANN technique. So first we should apply the ARIMA model to the original data set. After original data set, what is the error terms EI will comes, we can apply the ANN model for that nonlinear pattern to the data. So this will, the predicted value of ANN is denoted as NI hat, and the predicted value of Li will be the predicted value of ARIMA value. Adding these two, we get the hybrid ARIMA ANN model. So these are the matrix. What are the models whichever we are applying in our time series modeling? We have to identify the best performance matrix among this. So the model, whatever we are developing, whether mean absolute error or whatever the model we are developing, we have to calculate mean absolute error, mean absolute percentage error, mean square error, RMSE value to apply all the metrics to the model. Identify all the values should be minimum belongs to which model. That model gives the very good result for your prediction, especially forecasting values. So I am coming to the case study one, especially the forecasting the motor insurance claims, especially coming back to the motor insurance claims. Okay, claim forecasting is especially critical to the success of any insurance companies, because if the claim can be forecasted accurately, based on the claim what it is forecasted accurately in the future claim, especially premium can be adjusted accordingly, especially charging the lower premium with the competitor companies, which maintaining a sufficient buffer to make profit is for the company to stay in business, which lead to more customers to retain more profit. So the main objective of this is we have to apply different forecasting time series modeling to forecast the motor insurance claims. So we have the almost 15 lakhs data points has to be taken for last for 30 years of the data. We have applied the forecasting model, especially for all the models which I have explained, starting with the uh, regression model, and number two, exponential smoothing and ARIMA model, as well as ANN and hybrid ARIMA ANN model, by using the Python programming as well as R programming softwares. We got the result here while applying the generalized linear model, that is a regression model. We got the RMSE value is 1.183 and mean absolute percentage is 9.207. AAC value and BAC values are 3.174, 3.1744. And applied that second model, that is the ARIMA model. First, whether the model is in stationary or not, especially for applying the ARIMA model, I already told you that you have to plot the values. It shows any trend. Any trend, we cannot apply the AR or MA. We have to see for whether we have to apply the ADF test, that is called augmented Decker filter test, to check whether the data is stationary or not. So here ADF test is applied to the data set. It is clearly indicating that the p value, what we got the p value here. First we are applied the ADF test for the original data. The results of the ADF test shows it is not significant, especially the p value is greater than 0.05. So we are accepted the hypothesis and conclude that there is no significant difference exists between that value. So next we differencing the series. After differencing the series, one time we have differenced the series. The ADF test again it is applied to the same differenced model, differencing the model data set, and it clearly given 0.002. This clearly indicating that the ADF test statistics are highly significant. That p value is less than 0.005 or 0.001. Any level of significance, this p value is less than alpha. It can be concluded that the data is evaluated in stationary. So it is especially that ARIMA model, a lot of identification of, especially identification of P and DQ is very, very important. The parameters of P, DQ. Many researchers, it is found a difficulty in identifying the P, DQ. So what happened here? First, you have to identify whether the data is stationary or not, apply the ADF test for the original data set, check whether the stationary condition is exist or not. If the data is not stationary, you are differencing the series. So the arima p d q, the d refers to difference in the series. So I differenced one time, my p value is coming to zero point 0, the probability value comes to 0.002. This indicate that alpha is 0.05. It can be concluded that the data evaluated is stationary. Now difference in series, it comes to stationarity. So next I want to identification of what is the p value and q value. That means autoregressive parameter p value as well as moving average parameter q. For this we have to apply the ACF and PACF plots to our differencing the series data set to identify whether what is the p parameter p value and q value. Especially autocorrelation function plot will give the moving average parameter value, and partial autocorrelation function plot will give the AR model. So it is clearly indicating here, you have to see the lag. Autocorrelation plot is shows that what is the meaning of autocorrelation function. Autocorrelation function is nothing but the correlation of the time series with its own lags. Partial autocorrelation between, suppose if we have YT, suppose you have Y1, Y2 and Y3. So you want to find out the correlation between Y3 and Y1, excluding the Y2 in the middle. That means in the time lag, you have the time lag YT minus 1, YT minus 2, YT minus 3, YT minus 4. Suppose you want to find out the correlation between YT minus 5 to the original value of YT, current value, leaving the middle values, then that excluding the middle value, that will give the partial autocorrelation function. So that ACF and PACF plots will used to identify what is the parameter value of P as well as Q. So here, plotting the graph, it is clearly indicating that you have to identify the spike. The spike indicating that there is a significant, the parameter is significant, remaining are all not significant. It is clearly indicating that there is a partial autocorrelation function having one spike here, and autocorrelation function having one spike. So it is suggested that the autoregressive model having AR of 1 and PACF plot also showing only 1, MA of 1. So it is possibly we have to build the ARIMA model also to be considered as either 110 ARIMA model or ARIMA 011 or ARIMA 11. Especially ARIMA 111. We already got the P and Q is 111. We have to go ahead with ARIMA 111. So we have built the ARIMA 11 model. It is automatically giving the lowest value among other models also. And also that constants and AR of parameter value of pi 1 and theta 1, that equation value we got it. So we have applied the ARIMA model for the forecasting the claim amount. Okay, we got the mean absolute percentage error as well as AIC and BIC RMSE value. The same technique that ARIMA has to be applied to forecast the future values also. Then the same model we applied the ANN models also. Here we have assigned neurons. Neurons has to be assigned with the different neurons, and we have identified the mean square error will be very less. That mean square error, all the technique neurons 7, 8, 9, 10, we have assigned different neurons, and finally we got the mean square error value is very less. That is the neuron of 10. We are applied to the hidden layer was a neuron is 10, and we got the result. This regression plot also we constructed. The regression plot clearly indicating that training data that R value is 0.93. Validation is also getting R is equal to 0.9385. Testing data is 0.9326. And all together R value is 0.936. The perfect fit for the data for the regression line is 45 degree. If all the points fall near to the 45 degree angle here, the network output here, the fit is good for all the data set. So R value for each classes, if you see all the classes, it's above 0.93 for the, so this fit is good. What model we have established is the good model for this data set. Further, if you want to go for more accurate results were required, we can again retrain the network by considering the different neurons, different epochs we have to assign, and we have to run the model. So this validation also says best validation performance. It shows at epoch 27, it's the value is 0.17601, and the histogram plot also says here almost 0. that all the error value, target value as well as the output value shows the higher values. This is a negative, that is minus 0.0250 in the high peak. It is clearly indicating that the zero error, most of the values are zero errors. So error will be very, very less. So after comparing all the models, especially comparison of all the performance matrix, that is hybrid model and ANN, as well as ARIMA and generalized linear model, we can come to the conclusion that especially ANN model gives very less RMSC as compared with all other model of hybrid model as well as GLM. So what happened? This is the prediction which we got it for based on the ANN, which model is giving best model, that we predicted the future value, and this modeling process which helps the insurance companies to deal with the uncertain occurrence of the insurance, especially uncertain occurrence of the event of what is going to happen in the insurance industry. This exploratory machine learning approach would help the insurance companies to make their budget, to keep their budget for the future revenue planning, especially for the easy disbursement of the claim. This is the analysis we have done for the case study one. And next, one more case study we have done as deep learning approaches for predicting the USD, especially exchange rate INR prediction. Especially this is not the previous time series model. We went to little bit advanced deep learning approaches, especially in recent years. Forecasting using this deep learning models has gained traction, more traction, and lot of research is going on extensively studying this amount of accuracy. So we have applied a lot of deep learning approaches here. If you see, same, we started with the ANN model. So you already, I explained that ANN model is multiple hidden layers, which is known as a deep neural network. The deep learning model has gained popularity, especially for the complex pattern as well as representation of large amount of data. So we have taken the USD exchange rate for the last 10 years data, and we have applied the ANN model by using the Python programming, by inputting the layers, dense layers and all the thing coding. And we have here clearly indicating that the blue line represents the original data set and yellow is the prediction. But there are a lot of variations are there here. Some variations are there. Then we have applied a CNN. Especially most of the CNN approaches will go to image processing, especially 3-dimension set. But CNN 1D model, especially convolution neural network 1 dimension, which is adapted to the unique feature in the data set, we can apply that 1 dimension model for our time series modeling also. Because originally this CNN is developed for image analysis, and it has a remarkable capability in capturing the trend in the time series data also. So we have applied that CNN model for the consent data, and also LSTM also widely used a task involving sequential data, especially for the natural language or speech recognition and time series analysis. It have many application, LSTM, and making all this model, especially for the ANN as well as CNN and LSTM, we have created one more model which is called a GRU. This GRU also giving good result for the time series modeling of predicting the USD. Finally, we are combined at last we combined a hybrid as well as a GRU model of LSTM model. Both the model is incorporated. That is called, we call it as hybrid model. So we have converted both the models. That means we have applied first LSTM, GRU, LSTM model. What is the output we got it? What is the prediction we got it? That prediction which we got it, predicted value, we applied the GRU model in that predicted value. So this is the hybrid model. If you clearly indicating that if you see the previous models and this model, it is some variation is coming in the last end, but most of the data set points are fall in the blue lines. So finally, we have compared all these models, especially ANN, CNN, GRU and GRU LSTM as well as GRU LSTM. So GRU LSTM model gives very less mean square error, as well as R square is more, mean absolute percentage error value also less. So this, especially this analysis, especially forecasting the model USD dollar, which gives companies which is engaged in international trade can use this exchange rate forecast to manage currency risk effectively, and also it will be used for investment decision making, and also strategic planning of multinational corporation, Especially, it will be used for importing and export and policy formulation by the government and central bank. So this particular project is also helpful for government sectors as well as the private sectors. This is the second one more case study. The third case study, we have applied that deep learning and machine learning models to forecast BSE and Nifty Sensex IT index. Especially same in recent years, deep learning is more applicable in variety of field. So in modeling the time series, especially ARIMA model or machine learning approach, ANN and RNN and convolutional neural network for the BSE index or Nifty index for prediction how the trend is going on, which helps the investor to make more optimal strategies and also boost their profit. So previously, first one we are applied. I have for the case study we have applied for forecasting the claim. The second one is forecasting the USD dollar, and third one is forecasting the BSE and Nifty index. So here we have applied different models, which is ARIMA model and ANN model, conventional neural network 1D model, and LSTM model. All shows the prediction. This is the model which shows the prediction. The blue line is the actual value, and the remaining this is the prediction value, and here it is also the prediction as well as actual value is given. So the comparison of all these models, comparison of this performance matrix, we have applied all the techniques, and again we have identified that ANN model, here ANN model outperform other predicting models with greater accuracy and augmenting previous literature on the stock market analysis. Especially this, all the machine learning and deep learning approach helps the investor to design optimal strategies for them and boost their profit in their stock market world. So this all the models which I have demonstrated, especially even weather forecasting also we have done. Weather forecasting also the especially for the predicting the wind speed based on the temperature and humidity and all other parameters, we can do the we have predicted the values. So this especially here, I will 1 minute. I will so this analysis has to be done by using the Python programming code. Just a minute. Are you able to see the, ma'am? Are you see the
Yes, sir. Yes,
window?
sir. Yes, sir.
Yeah. So this is the BSE index model fitting the ARIMA model, what we have implemented here. Especially time series modeling, you have to download the stats model, TSA stat tools, and also import the ACF and PACF plot for import the model here, import the various functions. So this is the BSE data set. If you want to see the BSE data set, this is the uh, index data set. So this is the opening price and high price and low price. We didn't get for the 1999 actually. So we consider the closing price, but in the year 1999 we didn't get the data set for open price and high price and low price. So this is the, if you observe this data set clearly indicating this is a day wise, 1st February, 2nd February, 3rd February, 4th February. It's a day wise data set which consists of almost 5,600 600 data points, 5,600 data points. After some point we got all the values also. Some of the values we have from 2015, I think from 2015 we have the data set having the starting price as well as closing price and all. Closing price is in this column, okay. High price and low price, we got all the data set from 2015, but pre beginning of the data set we didn't get it. So because of that, when you are applying the model, you cannot consider all the columns into the picture, so that will affect the total model building. So what we have done here, if you observe here, we have imported the model of stats model, TSA. I'm running the model here. So again, import the, you know that Python, pandas and numpy is very very important, and matplot also important for statistical modeling procedure. We are imported that models here, and here we imported the read.csv file. This is the CSV file. I imported the CSV file here, and you can import, simply go to the folder here, and you can go to the folder and you can import where you want to import from your uh, where you have saved the file. From there you can easily you can import the data set here. So I already imported bsc.it.csv file here, so which you have here. I am assigning the data set, they read it the file and put df is the one, and I converted the data into natural logarithm. Sometimes the transformation of data is also very very important, transformation of the data in the data pre-processing. Why? Because in the 1999 the stock price is very less, but when you are coming to 2020, 21, 22, 23, the stock price of the same one will be higher. So the difference between the 1999 price of the stock and 2023 stock of the huge difference will come. This will affect the result. Because of that, sometimes we will apply the, especially in the time series modeling, we will apply some transformation of the data. Either we will take the log to the data, natural logarithm to the data, or we will take the square root of the data, some transformation. Otherwise we will do normalization of the data. So the data transformation is very very important before applying the data. Otherwise there is a huge difference from the beginning of the year to the last of the year. Okay, see, if it is if you observe here is itself for this data set, if you see 1st February 1999, the data set is 1,000 rupees close price of the particular things, and here in 2nd February it is 980 rupees, and 3rd February it is 1,003. But if you coming back to the 2021, it stock price comes to 31,638. Here 31,446. There is a huge difference between this and this. Okay, so by doing the normalization, by making the data should be in some proper format, applied the natural logarithm here. So the data has to be read here through the Python programming. And coming back to here, I have given the dropping the column, because when the data set which we have 4 columns, okay, which consist of date as well as I already told you, open price, high price, low price, and close price. But most of the data is based on the close price, so I dropped the open price and high price and low price. Okay, so that column will be dropped. Finally I got the close price. This close price I have applied the, here this is the close price, this is the close price. Close price I have applied the natural logarithm to the data set. So it is converted into natural logarithm. Now our data set is converted into natural logarithm of data set. So running that command and coming back to here, the results. I already told you, by applying the ARIMA model, we have to check we have to apply the ADF test first. First we have to see the data showing any stationary or not. Okay. So if we see here, I am applying the ADF feller test here. So the ADF test is showing that the p-value, especially the probability value, is 0.86462, which is greater than 0.05, that is alpha. So it is clearly indicating that the data is not stationary. The data is not stationary because we are accepting the hypothesis. It clearly indicating that the data is not stationary. So we have to bring it to the stationary. We have to difference the series. So for this p-value, if you see the plotting, ACF plot and as well as PACF plot, it is clearly indicating here. Just a minute. Yeah, you see the original data set. This is the original data set. I already told you that this is the original data set. It's showing some trend here. It is showing some trend. Okay, if the data showing any trend, definitely the data is not a stationary series. This is the original data set. So original data set, if you are getting the autocorrelation function also, it shows a lot of peaks here. And coming back to PACF plot, only 2 peaks are there. And already I told you that ADF test clearly indicating that the data is not stationary. So I have to do differencing the series so that it goes to ARIMA process, D value equal to 1. So here if you observe this code, okay, here differencing the series, here the command has given difference the DF of natural log. Natural logarithm is my data set. I'm differencing the series. I differenced the series now. If you see here differencing the series once, see how the data set is plotted like. Okay, it is showing some, it is not showing any pattern, right? It is not showing an increasing pattern. It is comes under, all the points will comes under in the normalized form. Okay, it is comes under the normalized form. Once if you're differencing the series, it comes under the normal. But even if you're differencing the series for one time, again you have to apply the ADF test to check whether the data is stationary or not. So the differencing the series one time, D1. Okay, so I am applied here. Again we have applied the ADF test. Okay, ADF test, if you apply, this is the ADF test. 1 minute. That shows the here itself ADF test is also it is giving. So ADF test is applied, it is predicting the values. And here you see that ACF and PCF plot. Here ACF is one spike here. This is the lag 0. You should not consider as a lag 0, because lag 0 is nothing but the correlation of YT comma YT. YT comma YT only, the time, first time, if you take the first time. But in this all the first spike, you have one spike is there, and even PACF plot also showing one big spike is there. So it is considered as a ARIMA 1-1 model. And by applying the, previously I told that you have to build the model, you have to put a stats model of TS stats tool import. And also when you are applying the ARIMA model, you have to give the import the model of ARIMA. But what happened when sometimes when importing the ARIMA model, it won't run. So because of that, I have downloaded we have implemented Sarimax model, seasonal autoregressive model. In that seasonal autoregressive model, what happened, the parameter says PDQ, and we have to give the seasonal order of P, capital P, D and Q, and season. In the season is nothing but 12 months. In the seasonal variation 12 months we have to give. So if you assign the value P, capital P and D and Q value 0, it straight away it comes to ARIMA model, normal ARIMA model. So for previously we built it, we kept ARIMA directly. We are not able to get some error, sort of error is coming because it is upgraded. So I applied the Sarimax model. Okay, but Sarimax model I applied here as a code, but I'm not given the value of seasonal ordering. I didn't give. Seasonal order is nothing but 000. So it clearly indicating the ARIMA model. It fitted the ARIMA model 1111. I got the parameter value and MA and sigma values. And after fitting the model, I have to forecast this, forecasted the predicted values and calculated the RMSE. So it is clearly indicating what is the RMSE value, mean square error, mean absolute error value. So here model, once it is forecasted, predicted, this is the predicted value. Once it is predicted, we can able to get the RMSE and mean square and mean absolute error. So from this RMSE and mean square and mean absolute R square value, we can put it in the table and we can compare the model. This will give you the ARI MA model. And just 2 minutes, I will ANN. This is also just I will show you because it's running, it will take time. Okay, here I have again that BSc IT CSV index file only I carried. You see here open price and high price, low price. I already told that in the beginning of the 1999 that values are zeros. It shows none. We have to drop this column. We have to keep the close price. So I have dropped the all the values. If you see here how the trend is going on, all the data points from the 1999 to 2022. The data points which we have done this analysis in the last before year. So here all the this is the trend. What I said, this trend only I shows that it is not stationary. We made it as stationary by differencing the series in by using the ARIMA model. So here for applying the ANN model, you no need to difference or anything. Okay, you can apply directly. So here it is clearly indicating data. I dropped the column of high, low and open prices. We got the data of date and close prices here. And straight away I've gone to here, price OT, closing price title. This is the original title. I applied the ANN data first. Before applying the ANN model or anything, first we have to split the data, training and test ratio. Here the data DF or index, that is the closing price is the data. The closing price data, if you see here, it will be what we say, it is converted into 80-20 ratio. Split the size. You have to split the size into 0.8. Suppose if this model only we can implement so many things. We can do 70-30 or 75-35 or 60-40. So here in this model we differ. We are splitted the training and testing ratio is 80-20 ratio. But sir, it is compulsory to go for 80-20. No, for universal truth we have to go for 80-20. Most of the researcher will follow 80-20 or mostly 70-30. That decided by yourself. But even if you want to go for most accurate, you can try all the ratios and check which model gives very less minimum error, that you take it off. So here it is splitted the data. Total 5000 data will split it into two, that is 4479 for training and 1120 for testing data. So we have applied the first Navy forecast model. Navy forecast model we have applied for this data set. After that, we went for Navy forecast. It is predicted the value. Predicted the value. This is the value. Here, what happened? That 20% what I have taken as a tested value. That particular prediction has given. This is the code for a Navy forecast. You can give the code of Navy forecast here. This is the data Navy forecast. Plot the time series values. Then after that, Navy forecast, we have implemented this mean square. Same, we have by using the Keras for machine learning approaches and identify the mean absolute error, mean square, RMSE, mean absolute percentage error. We got all the values for Navy based result. Then we have applied the horizon value 1, window size is 7 for implementing the ANN model. So implemented the ANN model, artificial neural network here. This is a ANN, and here ANN model fit. If you observe here in this TF Keras sequential model, okay, we layered the activation is activation function. There are different activation function that also you have to select on based on the data set. We have selected activation function is a linear, and epochs we have run at epochs also you decide the epochs, how much epochs, because it is a trial and error. There is no term how much epoch we have to use. Depends upon the model you can fix, but we have run so many epochs, so we kept 100, we kept 200, we kept 300, 400, 500 and 600, 1000 like that. And which model of shows very less mean absolute error value, that we have considered. So by using the training the model, we kept the epoch is 400 first. It ran the model 400, and after that the model evaluated the total mean absolute error and mean square error value, mean absolute error. After the result, we showed the prediction, how it is predicted, actual value and predicted value by using ANN model. And again, I already told you that second, here you see this epoch I run it with 100. Previously, we kept the 400, and here we run it with 100. 100 epochs, that also prediction shows, and we got the 100 epochs also, mean absolute error and all the things. Then we applied the CNN here, CNN model for again Kira's sequential model, and CNN model of convolutional model 4, and this also gives the absolute error and all the thing, mean square error. So after applying this model, what we got at the prediction, it's shown in the plot. Finally, all the models, LSTM, this is the LSTM model. Finally, we completed all the models. Then we come to the comparison. You see here, Navy based model, ANN model 1, ANN model 2, conventional 1D, and LSTM. So this data frame, what we got it, we compared all the values. The comparison shows here as a chart. We want to find out, sort the values based on mean absolute error. So based on the mean absolute error, suppose if you want to consider RMSE is your criteria, you can sort the value based on the RMSE. Finally, which one gives the least values among this all the models? So mean absolute error of CNN one dimension model gives very less error. So this model will give the best model. After getting this, this considered as a CNN is the best model. After that, we went through the prediction. Prediction is nothing but the future value, future prediction. We got future prediction. We have run it here. This is the prediction of previous values. So this is the values predicted of 300 values here. Prediction is based on the next data time. Next data time, we predicted the value 32,519, 32,552, 383. This is the future prediction of 100 data, the 350 data's prediction. So this data which we have predicted, we put it in the graph. It's plotted. It is showing some increasing trend. Okay, actually this is combined with so many data. If we expand this, you can it's showing one of the straight line equation, but if you expand this graph based on the x-axis and y-axis, automatically it shows some deviations will be there in the trend. So this is the future forecast. Whichever model, whatever we are building, especially in forecasting time series model. Future prediction is very, very important. That helps the company or government sectors to develop themselves. This is the overall conclusion for my time series modeling. Thank you. So, any questions? If you
Thank you,
have
sir.
anything, any queries or anything you want, if you need any help, kindly take my email ID, which is given in the slide, and the phone number. Or you can try to contact me, because most of the analysis which I am doing, my papers, all the papers will be related to the machine learning and deep learning approaches only. So any help which is needed for your research or anything, kindly contact me anytime. Thank you.
Thank
Yes.
you, sir. Thank you for your valuable presentation, sir. So,
Thank you.
participants, you have any queries? So, so participant, do you have any queries? Kindly unmute your audio and ask the queries. Setting no queries. So now I request everyone to turn on your video for the photo session. Sir, Selvakumar sir, kindly turn
Yes,
on
ma'am.
your
Yes,
video,
ma'am.
sir.
Yeah, yeah. One minute. Yes, ma'am.
Thank you, sir. Thank you, sir. Thank you, participants.
Thank you, ma'am. Thank you, Maniman sir. Thank you so much.
Thank you, sir. So for the closing remark, I would like to call Ms. P. Jaisha, Department of Mathematics, to deliver the vote of thanks.
Good afternoon, all. I extend my sincere gratitude to our esteemed founder, Father Dr. J. Arulraj, for his continuous support and vision that led to the successful organization of the Faculty Development Program. A special thanks to Dr. V. Selvakumar, Speaker of today's FTP, Bhavan's Vivekananda College of Science, Hyderabad, Telangana, for sharing valuable insights and expertise during the FTP contribution significantly to our professional growth. On behalf of National FTP organization, by Department of Mathematics, St.Joseph College, Arts and Science, Kovur, Chennai, I extend my heartfelt gratitude to Dr. Janaki, Dr. R. Krishnakumari, Dr. Ammu Kudzia, and Dr. V. Prakash for their invaluable contribution to the National Development Faculty Program. Their expertise from Savita Engineering College, SRMIST, Muhammad Sadak Engineering College, and Dr. Ambedkar Government Arts College has enriched our academic discourse, leaving an indelible mark. Thank you for your enlightening insights and commitment to fostering educational excellence. I express my appreciation to Reverend Sister M. Baby, our beloved administrator, for her unwavering encouragement and support throughout the planning and execution of the FTP. My heartfelt thanks to our respected principal, Dr. R. Ruben, for his commitment to fostering a culture of continuous learning and development among the faculty members. I acknowledge and appreciate the participants of faculty members from other colleges whose diverse perspectives and experience enrich the discussion during the FTP. A special mention to the beloved Head Department of Mathematics, Mrs. Sujata, for their guidance and supports in ensuring the success of the FTP, showcasing the dedication to enhancing the academic excellence of our department. Last but not least, I express my gratitude to my faculty members for their active participation and enthusiasm throughout the FTP, making it enriching expertise for everyone involving. I also extend my thanks to Mr. P. Harish our technical team head, for his full cooperation during the FTP. Together, your collective effort to have not only made this FTP a success, but also contributed to the continuous growth and development of our academic community.
Thank you, ma'am. So we request everyone to fill out feedback form which has been posted in the chat box. So participants, do fill your feedback form which has been posted in chat box. Thank you for your participation, participants. So kindly fill. So participants, kindly fill out the feedback cum attendance form which has been posted in the chat box. So meet you all in next program. Thank you all for your participation.
Ma'am, it shows fourth day link. The feedback link shows fourth day link.
Ma'am, we will
The feed
update our it's updated, ma'am. So thank you, participant. Thank you for your participation. Thank you all.